X-Plane 11 is a newly released simulator by developers at Laminar Research. Laminar Research has always boasted that X-Plane is the world's most realistic simulator. The question is it true? In my opinion, yes it is, and the main reason is because of how they model their aircraft and the physics behind everything. In a traditional simulator, developers usually use stability derivatives to do modeling. By doing this, they look at different data refs, such as the airplane's speed, heading, wind direction, thrust setting, and so on. And then they plug these into equations to model the airplane's flight characteristics. For example, we have an airplane, and he's cruising at Mach 0.8. The simulator would plug this into an equation for drag, and then crank out a number for the total drag on the aircraft. The program would then compare this to total thrust and display the correct flight characteristics of the aircraft. The problem with this method is it assumes the plane is one object. X-Plane uses something called blade element theory. The best way to describe this is by using an example. Let's say we have a propeller. When we spin the propeller, this propeller will generate thrust. Using a stability derivative, we would just calculate thrust by doing something like 20% thrust, therefore 500 newtons, because the equation said so. And as accurate as that can be, it's still assuming an average force exerted by the whole propeller. But this fails to consider many crucial elements. If we label the propeller at two different spots, point 1 and point 2, we know that when this propeller spins, point 1 will travel faster because it will be further out from the center of spin. We also need to consider that the bite of the blade at each position is slightly different. So what blade element theory does is it cuts up the propeller blade into a bunch of segments, just like as we're shown in the picture, and then does calculations for each part to determine what forces are being exerted on each point of the blade. They then add this all together and apply it to the whole prop. This method is actually used by engineers to help design aircraft. It's a lot more accurate than stability derivatives. X-Plane actually takes this a step further. The software will use blade element theory on the prop to find out the thrust and how it's spread on the blades, but it will also use blade element theory on the wings. In some detailed aircraft, the wing is cut into over 100 pieces to find the most accurate lift values at each point. X-Plane will also use blade element theory on the fuselage and the tail. What we get is an incredibly accurate blueprint of what forces are acting on each tiny piece of the aircraft. What X-Plane does next is compiles the data to compute how the plane would behave as a whole, and therefore how the plane would fly. Here is a screenshot of the default Cessna 172 in X-Plane 11. I have configured the simulator to show the blade element theory in action. All those green, yellow, red, and white lines are force vectors on different parts of the aircraft. X-Plane then takes all those vectors to calculate the aircraft performance. If we look on just the left wing, we can count 20 vectors on one wing. Take into mind that this wing is only barely over 15 feet long. So with an airliner that has a 100-foot wing, imagine the accuracy that can be achieved. Which is why I believe Laminar Research's X-Plane series is the world's most realistic flight simulator, just like they boasted. To end this off, I just want to say safe flying and hope to see more users joining the X-Plane community.